This is a problem from your lab assignment, section 5.4. It says here that we want to evaluate this integral. This is an integral from 0 to 5 pi over 3 of 8 sine theta plus 8 sine theta times tangent squared theta divided by secant squared theta d theta. So we want to find the antiderivative of this function. The best thing that we could try to do in the beginning is try to simplify this function. So it looks like they can factor out an 8 sine theta. So if we factor out an 8 sine theta here from this first term, we're going to get 1. And then if we factor out an 8 sine theta here, we're going to get tangent theta. And then this thing is going to be squared. So I think it's okay. Might be safer to put parentheses around here, but I think this should work because we're not squaring the theta, we're squaring the whole tangent. All right, let's see if this is correct. Okay, looks good so far. Now we know the trigonometric identity of this thing. Well, I don't know if you guys know that off the top of your head, but we know that sine squared x plus cosine squared x is equal to 1, regardless of what x is, if x is theta. Now imagine dividing this whole thing, or dividing each of these by cosine squared theta. And what are we going to have? We're going to have this whole thing is going to be equal to 1. This whole thing is going to be equal to tangent squared theta, or x. And 1 over cosine is secant. Let's see, secant squared of theta, or x. So our result here is going to be secant theta squared. Secant squared theta. So that's our trigonometric identity. And so we can replace the numerator with 8 sine theta times secant squared theta. So we have 8 sine theta divided, or times, because we're multiplying by 1 times tangent squared theta, which is equal to secant squared theta. So times secant theta and squared. And meanwhile, the denominator is also secant squared theta. So I suppose we can cancel here. I don't know if they want us to cancel here or the next step, but let's just cancel here. So this thing's gone and this thing's gone, and so all we have left is 8 times sine of theta. So this is what we're going to integrate. The antiderivative of sine theta is going to be cosine theta, but actually it's a negative cosine theta. So don't forget that negative sign. It's going to be important. Cosine theta. So that's our antiderivative, and there's an extra 8 out there that we're going to pull out. So we'll pull out an 8, or we can keep the 8 on both of them, and then we have a negative cosine squared theta, or cosine theta, sorry. So according to the fundamental theorem of calculus, we're going to find the antiderivative, which we found, and then we're going to evaluate it at 5/3. Now 5/3 in a unit circle, 1/3, 2/3, 3/3 is pi, 4/3, and 5/3 is in the 4th quadrant, and the cosine, well, let's see, minus 8 times the cosine of 5/3. Okay, let's take out our unit circle. So here's our unit circle. 5/3 is in the 4th quadrant, and the cosine is the x value. So the cosine and the x value at 5/3 is 1/2 positive. So it looks like it's going to be 1/2. And then the cosine of 0 is 1. So that's 1 times -8. All right. And then we can simplify this. This is -4 minus -8. So that looks like it's going to be +8. -4 plus 8 is going to be +4. Okay. So that's our problem.